Hello everyone, welcome to another video where we can talk about colorimetry. Before start, I want to promise you, I want to go into my plans for this colorimetry. Colorimetry, first of all, we'll talk about basic information that you must know. After that, we'll talk about two types of colorimetry. Two types of colorimetry. So requirements. And also application. And after that, we will talk about advantages and the disadvantages of this method. So before start, let's talk it. Colorimetry is an electrolytic method of analysis that is based on measuring the number of electrons used in a chemical reaction. So let's try to understand it. Colorimeter is a method of analysis when it's based on measuring the number of electrons used in chemical reaction. So if you understand, we have a colorimeter, we divide into two groups. Control potential. Second one is constant current. It's very popular as a coulometry determination. Pretty sure you hear about that. Okay, controlled potential. I'm sorry guys, I'm pretty bad at writing. So we divide into two groups. The control potential technique, in which we apply a constant potential to the electrochemical cell. The potential of the working electrode is maintained at a constant value related to the reference electrode circuit electrolysis. The current Q is recorded as a function of time. So what we have to understand is this method, control potential, the potential of the working electrode is maintained at a constant value related to a reference electrode towards electrolysis. Let's repeat What does it mean? Colorimetry. Colorimetry means is an electrical method of analysis that is based on measuring the number of electrons used in this chemical reaction. Type of electrolytic methods based on measuring the number of electrons used in a chemical reaction. Let's think. Plus two electrons give us two. Let's repeat again. Colorimetry is an electrolytic method of analysis that is based on measuring the number of electrons used in a chemical reaction. Okay. Let's talk about constant current or colorimetric titration. Colorimetric titration based on measuring the measuring the combining capacity of the analyte with the standard reagent. The reagent consists of electrons and is a standard solution. The constant current of a null magnitude. Electrons are added to the analyte until the endpoint is reached. The amount of analyte is determined from the magnitude of the current by the time of the completed titration. Let's just I'm very lazy. I don't know. I don't want to talk too much. I'm sorry about that. Just pour it. You know what? Just I've been learning. I've started learning. Yes. Oh my God! I'm still doing nothing while on my weekend. Just get bored. I want to stop here and go outside. But unfortunately, I can't because I have already started to record this video. I can't get another chance to record this video again, so let's continue. Colorimetric titration based on measuring the combining capacity of the analyte with a standard reagent. The reagent consists of electrons and the standard solution. The constant current of null magnitude. Electrons are added to the analyte until an endpoint is reached. The amount of analyte is determined from the magnitude of the current and the time required to complete the titration. So, before we start here, let's move to the what consists of instrumentation. Instrumentation is instrumentation. Let's start from the first one. Control potential colorimetry. It consists of from three parts. Electrolyzer cell, potentiostat, device for determining the charge consumed by the analyte, which is called electrometer. Electrolysis salvages obviously potentiostat, generally automated and equipped by computer or an electronic parent. Gives this part gives the charge and the columns necessary to complete the reaction. The next one is colorimetric titration. Consists of five parts: current source, titration cell, switch, timer, current meter, okay, let me repeat again. Controlled potential consists of three parts: electrolysis cell, potentiostat, and the third one, device for determining the charge consumed by the analyte. Next one is colorimetric titration. Consists of five parts: current source, titration cell, switch, timer, current meter. If we talk about the techniques of analysis in general, colorimetry may be used for the quantitative analysis of both inorganic and organic compounds. Application is control of potential, electrolytic demonstration, and the synthesis of organic compounds. What about colorimetric titration is also you can apply all the type of volumetric reactions, such as neutralization titration, and both of them are oxidation reduction redox titration, colorimetric titration have been applied for many redox titrations. Well, let me tell briefly about advantages and the disadvantages of these two methods. Advantages: no need to prepare standardized or source standard solutions. Can prepare unstable reagents since they react almost as soon as they generated. Fluorine, bromine. A single colorimetric titration apparatus can be used for redox, acid-base precipitation, complex metric, and titrations. Disadvantages is that relatively higher cost requires highly trained personnel, long setup time, limited life of electrolyte cell, low sample throughput.